I have to calculate the error. So I have to calculate the error means what I have to do. You can calculate the individual errors because there are two outputs are there and the two actual outputs also no, but I have calculated the total error. So total error is nothing but summation of half into target minus output square. Okay. So half is used just it get cancelled when you differentiate it. Okay. Now substitute the values. The target I know, output I know, you got error with respect to the first output neuron. Okay. Similarly, error in second output neuron. Okay. Use this formula, you'll get this. Total error is what you add, you'll get the total error this. Okay. So this is my total error. So this must be zero actually, but I'm not getting zero. Okay. So what I have to do, because there is an error, the inputs are not properly matched with the output with these weights that I've given. So I have to tune these weights. So for that I have to move in the backward direction. Okay, because these weights or biases are the free parameters. Then okay, same thing is repeated for the next neuron H2. H2 is the second hidden neuron. Okay, so you calculate input to the hidden neuron. So I hope everybody know how to calculate input to this. So whatever the input you will get, you pass it to the activation function of 1 by 1 plus e to the minus of that input that you have got. So you'll get the desired output. Okay, so let me show you. So out of H1, so this is net input to the hidden layer, and what is an output of that hidden layer one, hidden layer of neuron 1 H1. You pass it to the activation function, you'll get this. Okay, similarly for out of H2 you'll get this. So I've got the output of the hidden neurons. So I've got the output of this, I've got the output of this. So this output will be multiplied by this weight, this output will be multiplied with this weight, again the same process plus bias. Okay, so you calculate the input to this output neuron. So let me show you here. So there is a net input to the output layer, the layer neuron 1. Okay, so multiply the weight with the corresponding output of H1 plus similarly for this, the same linear combiner W1 x1 plus W2 x2 plus by same